All right, Trig, here we go. We are making your notes video for Wednesday. Not Wednesday, it's Thursday. Thursday, November 7th. You're probably getting this on Wednesday. All right, today we're brought to you by book you should all read this winter. Viktor Frankl, Man's Search for Meaning. And, you might want to get this one day when bad things happen to good people. All my bobbleheads are turning their backs to me. Whatever. All right, so number one, this is section 5.2, and the title of 5.2 is Verifying Trig Identities. Okay, I want you to take these notes. I also want you to look at numbers 14 through 17 in your Trig Quarter 2 ACT test. 14 through 17, do those. We'll talk on Friday. Obviously, practice for your exam number 2, the trig graphs. Perform each operation and simplify the result. All right, so it's tangent theta, cosine theta. So first off, tangent theta is sine over cosine, and cosine is just cosine. So we're going to rewrite, always rewrite tangent and cotangent and secant and cosecant for the most part in terms of sine and cosine. Then what happens? This is great. It's about as simple as an answer you can get, okay? All right, so it's kind of a potpourri of just simplifying we're going to do here. We're not verifying any trig identities yet. Okay, so let's take a look at this one. So sine squared over cosine squared, and then this is sine times cosecant, CSC. Well, cosecant is 1 over sine x, so sine x, I was going to cancel, give you 1. Right, like here you might be confused because cosine squared can be 1 minus sine squared can be 1 minus cosine squared, but this can also be written as the following, like sine x over cosine x, squaring both, because what is sine x over cosine x? It's tangent. And if they're both squared, it's tangent squared. And this is one of the Pythagorean identities. This one's definitely a little bit harder. Okay, tangent squared x plus 1, and tangent squared x plus 1 is in fact secant squared. So that's a pretty nice answer there. Now, that's one way. If you're like, man, I really don't like that. I wasn't gonna think like, how can I also get that number? Well, I could have just had, you definitely need to know this, okay? You're gonna have 1. And then you can simply multiply top and bottom by cosine squared. So you're gonna have cosine squared in the bottom, and look at your numerator. It's gonna be sine squared x plus cosine squared x, which is 1. All right, so now you're gonna have 1 over cosine squared x. And 1 over cosine is secant, so that's another approach you can have here. These are just going to take a lot of practice, all right? Cosecant, secant over cotangent, all right? So cosecant is 1 over sine, secant is 1 over cosine, and cotangent is cosine over sine. Just put everything in terms of sine and cosine and go from there. All right, so 1 over sine times 1 over cosine, it's 1 over sine cosine. And then if I'm dividing by this, I'm going to multiply by the reciprocal of this, so it's sine over cosine. So the sines are going to cancel. Cosine times cosine is cosine squared. And I literally have the same situation as I did in 2, where it's 1 over cosine squared, which is secant squared. Pause this if you need to. I need to have 2. Got to make 2 videos here. Don't want them both to be 25 minutes. All right. All right, so again, example 4. Here's what we're working with. 1 plus sine theta squared plus cosine squared theta. I'm going to FOIL this, square the first term, square the second term. The inner product is sine theta, double it. Works just like regular foiling. All right, so this is this. Now, sine squared plus cosine squared is 1. You need to be on the lookout for cosine squared theta plus sine squared theta, or sine squared theta plus cosine squared theta. You need to be on the lookout for that because that is 1. 1 plus 1 is 2. 2 plus 2 sine theta is a relatively nice answer. You can pause this when you need to. All right, secant over cosecant plus cosecant over secant. All right, so here's what's going on. Secant is 1 over cosine. Cosecant is 1 over sine. Same thing here. Again, I'm showing a bunch of work here. And to divide by 1 over sines to multiply by sine. All right. To divide by 1 over cosine is to multiply by cosine. To divide by secant is to multiply by cosine. It makes sense. So sine x over cosine x over sine x. Similar situation today. We had this today. Similar situation. Yeah, that's okay. I don't know why I made these. No, I made these answers earlier. I don't particularly love that. Like that that is an okay answer, but here's also another answer. This has sine, it needs cosine, right? So I have sine x, cosine x, plus cosine sine. I mean, if you gave me this answer here, can't count you wrong. So this fraction is going to get sine over sine. This one's going to get cosine over cosine. So you're going to have sine squared plus cosine squared all over sine cosine. Which means you're going to have 1 over sine cosine. That is interesting. Which is the same thing as cosecant secant. What? Wow. That looks good. All right, so a lot of different answers there. Which, probably doesn't make some of us feel great. They hit a few different answers. But again, just slow and steady. Not being quizzed on this next week. All right, the other day we wrote that sine of negative theta is negative sine theta, and we wrote that cosine of negative theta is cosine theta, because cosine is even, and sine and tangent were odd, so we wrote this down the other day. All right, so sine of negative theta, that's just the opposite of sine theta. Cotangent is cosine over sine. So I'm going to take negative sine theta, I'm going to multiply it by the reciprocal of this, and it's not a great answer. Not a particularly great answer. We're just going to leave it like that. All right, now we're verifying identities. So the nice thing about verifying identities is that you know what the answer kind of has to look like, because you have a statement of equality, and here's the statement. We've got to verify this. Cotangent theta over cosecant theta is equal to cosine theta. We had to show that this is true. Usually you want to start with the side that's more complicated. Cosine is very uncomplicated. So I'm going to rewrite cotangent as cosine over sine. I'm going to rewrite cosecant as 1 over sine. I'm going to take this, multiply it by the reciprocal of this. Look how sines cancel. I'm literally left with cosine. Just doing something in my picture here. Cosine equals cosine. I think back in the day we used QED, I think Latin for it's been solved or it's been proved, something like that. And we used to use a box. Sometimes you'll see a little box when a proof is done in a higher level math class. You see a little box. Anyway, I just put a check mark, they're equal. There it is. Showed it. All right, so tangent of alpha over secant of alpha. Show that that's equal to sine alpha. Again, sine alpha, very uncomplicated, so I'm going to work with this. Tangent is going to be sine over cosine, and secant is going to be 1 over cosine. It's basically the same type of question as example 7. Give me the easier ones today. Sine alpha over cosine alpha, divided by 1 over cosine alpha. That means I'm going to multiply by the reciprocal of this. Cosine alphas cancel. That means I have sine alpha equals sine alpha. Check mark or a little box. It's been proven. All right. Take a look at 9 and 10. 1 minus sine squared beta over cosine beta is equal to cosine beta. First off, so we need to know this. Sine squared plus cosine squared is 1. That means 1 minus sine squared. You see that? If I move sine squared over, that means cosine squared is 1 minus sine squared. We wrote that down as well. So that's what cosine squared, in this case beta. 1 minus sine squared beta is cosine squared beta. Well, cosine squared divided by cosine is just cosine. So cosine beta equals cosine beta. You can take your time, rewind it. Example 10, we have sine squared theta over cos theta. It's equal to secant theta minus cosine theta. I mean, some of you might be like, this looks more complicated. And, make the case for that. But I don't like this exponent. We're going to get rid of this exponent if we can. So sine squared is 1 minus cosine squared. Again, you could have worked from this side. You can maybe show me how it works out. So sine squared is 1 minus cosine squared. If you have 2 terms in the numerator and just 1 denominator, you can break it up. You say 1 over cosine minus cosine squared over cosine. You can break it apart like that. But 1 over cosine is in fact secant. Cosine squared over cosine is cosine. So I have secant minus cosine, which is what I had here. If you didn't like that, you're like, this looks more complicated. You could say 1 over cosine minus cosine over 1. You're going to multiply this by the following. This actually might be quicker. And then you're going to have 1 minus cosine squared, over cosine. What is 1 minus? This is actually faster. 1 minus cosine squared is sine squared. Sine squared theta over cos theta. And then you would say equals, and you would bring that down. Well, you know, look at that. Look at that. Folks, I think that's it. All right, I don't have anything written on 4, so that's example 10, great. So here's what I want you to do the rest of the time. I need for you to do questions 14 to 17 on the ACT packet at least. Study those trig graphs. Let's be ready to go on Friday. This is Yak Math Videos, signing out.